Hey, good morning, USA. Mr. N, another proficiency exam type of problem, number 5. As you guys can see here, there's a triangle, and more than that, there's a right angle, right? So many of you will think about that Greek guy that made our life easier, or some will say made my life a misery, right? In the right triangle RTW shown below, the length of side WR is 3 meters and the length of side RT is 8 meters. What is the length of side TW? Okay, and you have 4 options. And everybody will start saying, yeah, Pythagoras theorem, Pythagorean theorem. This is what? This is 6th grade math, this is 7th grade math, 8th grade, no more than that. Those were the years where you probably heard first time, or maybe first grade, maybe kindergarten. I know some of you guys, um, maybe there is an S over there. Maybe some of you heard about this theorem before, okay? And what is that theorem saying? Well, that theorem, many of you will recall it like automatic um, rhyme or song or line here. You guys, when you hear Pythagoras theorem or Pythagorean theorem, you'll say, yeah, a squared plus b squared equals c squared. And you may think that you're so good and you got it, but I will say, you know what? That's nonsense. And why is nonsense? Well, it's nonsense yet because when you say that, you need to tell me more about A, B, and C related to a right triangle. And what is that? Is the fact that A and B, to verify Pythagoras theorem for a right triangle, they have to be the legs of that right triangle, the shorter sides, right? Which shorter sides are perpendicular to each other, and the longest side, hypotenuse, um, all three of them will verify, will check into this relation if, like I said, this triangle is the right one, or if you have three numbers, three lengths of, of the sides of a triangle that verify this statement that, the square of one of them plus the square of the second one equals the square of the third one, you will know with 100% certainty that you're talking about a right triangle. Okay, so let's go back here. Applying Pythagoras theorem, what can you guys say? Well, A is what? A is 3 for this problem. How big is your C? Well, C is 8, right? And B is the missing one. We have to find B, which in this problem, they call it TW because your triangle RTW is the given triangle. Well, go back and plug in everything that you know, right? So whatever you have A into your relation here, a squared plus b squared equals c squared, instead of A, you will write what? You will write 3. So I have 3 squared plus B. Do you know B? No, you don't. So B will stay the same way. B squared equals c squared. What is c? Well, c is given and is 8. Equals 8 squared, right? Now you have to solve for b. And because I want to solve for b here, I will take that 3 squared away. And I will take it away from both sides, because that's the way we learn to solve equations. You do everything that you do to the left side, you're doing it to the right side, okay? You slap one cheek, you're going to slap the other one, because otherwise that guy may not be so happy. 3 squared minus 3 squared, 0. You have what? B squared left here equals 8 squared minus 3 squared. Now you can just go ahead and find what is that. What is a squared, right? A squared is 64 minus 3 squared is actually what? 9. And what you get here? 64 minus 9. That's going to be what? 55. Okay? So your b squared is 55. Now, if you want to find b, because you're looking for the length of that side, right, not the square of that side, you take the square root. And you take the square root of all the sides here, right? And it looks like square root of b squared is b, we know that. And that will equal square root of 55. Now you may think about ways to simplify the square root of 55, but there is no simpler way. And if you look back at your possibilities here, it seems that yes, there is an answer that equals square root of 55, and that will be your answer. You are done, and you're moving on. Okay? See you next time.